I am on a quest. I want to find out how to make software and hardware perform at their peak. I want to know how to make applications faster and more efficient. And while I'm at it, I want to have a little fun. Don't think I can do it? Just watch me. I'm Scott Moore, and this is the Performance Tour.
Hey everybody, just hanging out at the lake like everybody does during the summer. This is Scott Moore, and this is time for another edition of the Performance Tour. One of the topics that keeps popping up everywhere I go is the question about, can we do continuous performance and how easy is it to pull it off? It's easy to say, but it's really difficult to do from what I've learned and what several other of my colleagues have told me. So let's go back to Atlanta when we recently did this live event. And let me tell you, if you're missing these live events, this is not something you're going to get anywhere else. There's information that we share in these events that really help people, but you got to go there and be there when it's taking place. But we had a lot of fun. One of the things I did was met with Bryan Cole of Tricentis, who is the director of customer engineering there over the Neoload product. And that's one of the things that Neoload focuses on, is the aspect of continuous performance testing. So I grabbed Bryan for an interview where we could talk about that subject. Okay, on today's Performance Tour episode, we have my good friend Bryan Cole.
Nice to see you again, Scott.
Thank you very much. It's good to have you on the show. So for those who don't know you, why don't you introduce yourself to our audience?
Sure. So my name is Bryan Cole. I am the Director of Customer Engineering here at Tricentis. I like to say this is an elaborate title that really means I'm responsible for helping customers get more value from their existing Neoload investments. And I work with both the sales team to help onboard new customers as well as existing customers to walk them through the complexities of what's changing in the industry, what are the new trends that are going to be coming along, how do we deal with this thing called Kubernetes, what about CI pipelines, all of the complexity that comes from that. When I have spare time, when I'm not doing that, everything I talk about is evangelism and advocacy, the importance of performance engineering and why you should do it. I write a lot of blog articles, I do a lot of webinars, I sit in a lot of roundtables. So I'm very engaged with the industry, and I'm pleased as heck to be here with you, my friend.
Awesome. You're one of us in the community.
20 some odd years of performance testing under my belt. So
Bryan, the subject matter today that we're talking about is continuous performance. Making performance in a continuous pipeline along with development, along with everything else that we're doing in a continuous way. You hear from a lot of customers across the board. What are you hearing in terms of the maturity level of companies? Do they get it? Are they struggling with it? And what type of questions and feedback are you getting about continuous?
So in terms of the customers that I'm speaking with, I would say probably about 5% of them say, we get this. We have it embedded in our tool chains where it's appropriate. We know what we're doing. We're solid. We're good. Beyond that, probably another 5% are on the journey. They have it in some of their tool chains. They're experiencing some problems or difficulties they want to talk to us about, things like scaling of their performance testing infrastructure or dealing with Kubernetes or things of that nature. Another maybe 15% are right on the cusp of taking that journey, beginning those steps towards including performance as part of that tool chain, but are looking at the technical next steps and are a little daunted by what they perceive as a lot of the complexity. And it is complex. We do want to make it as easy as possible. It's the whole purpose and behind the reason of the existence of Neoload, but we don't want to also just paint, absolutely, push this one button and everything will work. It is difficult. But beyond that, everybody else is looking at implementing performance into a continuous pipeline and thinking to themselves, we don't really need that. We have a traditional performance engineering strategy. It's served us well. We're not experiencing any performance issues or velocity problems. So we're good. We don't need to invest in this journey. What I've seen over the last year is those numbers very slowly but relentlessly shifting towards everything going into the CI pipeline. All of your performance testing being driven not by clicking start test and neoload, but by a step of your CI pipeline execution triggering neoload. I view that as an inevitable progression, that the vast majority of your testing will happen that way. This plays into kind of two big industry trends that are taking place. The first is the availability of your infrastructure and licenses to really optimize the use on that front. And this is a big problem a lot of our customers are facing about how do I take a team of performance engineers and all of a sudden scale them so they can support 25 development teams. And this is not an easy answer. There's a lot of nuance that can come from this, and it will vary organization by organization. But finding the right solution for you based on how many different customers we serve and what we've seen work and what we've seen not work, and the advice and guidance that we as a vendor can provide to you is something we're very happy to share. The other big challenge that we see is that technical gap, that transition. A lot of traditional performance engineering teams have mastery over their performance testing solution, hopefully neoload, but they don't have a lot of exposure to systems like source code management repositories, CI pipeline, workflow code, Kubernetes, and these newer technologies that are going to be instrumental in what the future of a performance engineering effort are going to, that it's going to involve a change in their skill set, a shift in their perspective, and getting involved earlier in the DevOps tool chain.
All right, so you brought up a lot of points here, and the numbers that you're talking about, these percentages, that really matches what I have experienced anecdotally out there in the market as well, talking to a lot of folks. I'm still surprised that we're actually in that state right now, because we see products like Kubernetes maturing so fast, and the use of them, the gradual use of them, it's not anymore like it takes 2 to 3 years, it's like 12 months. Everybody's starting to use this thing again. And so from a performance standpoint, I would have thought it would have matured more. So from what you just said, is it a skills thing because it's harder to get people who have the performance testing and load testing background with these new technologies to be able to test them and make them continuous? Is it something else? Is it that we have the wrong roles trying to do it? Or how do you think we speed this up where more people are doing it?
So part of it is organizational and cultural. To your point about the skill set, if you dedicate a performance engineering team to managing this, you're asking someone like myself to change the oil in your car. I'm going to pop the hood, look, and see if there's an engine in there, and that's the extent of my knowledge. I don't know what the problem is, the engine's still there. So really involving a broader team. You need somebody who has some Kubernetes expertise to really set up and manage things like dynamic infrastructure. The nice thing is once these things tend to get set up from a test infrastructure perspective, they're set up. They just continue to work in the background flawlessly. If it's not broken, don't fix it. Nothing needs to change. Everything just keeps flowing normally. So that initial setup can be complex and you do need some expertise, but you don't need it in the long run to manage a lot of that stuff. So that same thing with teaching a performance engineering team how to use a software source code management repository. Something like Git. Git has taken over the world. It's great. It's all over the place. Neoload is a Git client in every respect and can interact with these repositories. It's a great way to share your projects and your work between teams, but it's very foreign to a lot of performance engineering teams. Not difficult, just different. And that's a step that can be taken, and it's way easier if you have an expert in how these tools work, which you will find if you make friends with the development organization. So a lot of these knowledge gaps can be pretty easily closed, and most enterprises that I speak with have pockets of this expertise floating around, and it's just a question of connecting them to the teams to broaden that exposure. The other side of it is more cultural in terms of things like the velocity of your releases. If you find yourself with an organization that is okay with pushing out software releases once a quarter, and they don't need to go faster than that, your incentive to embed performance engineering into the CI pipeline diminishes sharply. There's no reason to go through all of this effort and gain all that velocity because there's no return on the value for it.
Right.
It's where you start seeing that acceleration and release cadence that's going to drive this cultural shift. This is also something I view as an inevitable progression. Containerization is not a fad. It's going to be de facto, in 10 years, everything will be running in containers. The idea of running a virtual machine image is probably going to go away. Everything will be containerized. But before we get there, that gradual shift, this is how you as a performance engineer can prepare yourself for what the future is going to be like. Start reading about these things, start understanding what they are, those fundamental pieces. It can only help you in the long run because this is where the world's going, but it does cause another problem once you start getting there. And this is where we start talking about the velocity of those tests goes up sharply, which means you have a lot more test results. Analyzing a performance test is not simple. There's an art to it. There's a feel to it, right? There's something that only experience can give you when you're looking at those graphs, thinking to yourself, I know there's a problem here. I can see it. Even though when you show the same graph to somebody else who doesn't have that background, they don't see the same thing. So that skill set, that domain knowledge, is going to come under a lot of stress if you implement performance engineering into 25 development teams who run 3 to 5 different pipelines and run those pipelines 3 to 5 times a day. You're going to get hundreds and hundreds of performance result sets coming towards you. This is where we're going to see a rise in artificial intelligence, the parsing of the data, the understanding of what is in these files, what is this stuff telling me, how does it change over time, where do I engage, and how do I leverage the expertise that I have? Because it's going to become a limited resource, which means it's also going to be a valuable resource. So good news for the performance engineers out there, your job isn't going away, it is going to transform.
So to what you just said, this is much easier said than done. We want continuous performance. Make it so, number one, right? It's not that easy, right? So just from a practical perspective, can we just walk through a hypothetical? This is how we would build a continuous performance process.
Yeah, so there's 2 main avenues or on-ramps to this journey. And the first is when you as a developer need to execute load or performance tests against some small software component you're building. We're talking APIs, web services, things of that nature. This can all be done programmatically. Neoload comes with a robust CLI. Any good performance tool will have a command line interface associated with it. Leverage that CLI, take advantage of it, trigger these tests from your IDE, from the command line, from your Jenkins pipelines or Azure DevOps pipelines or whatever, and invoke these performance tests as a par for course what you're doing. And you can save it all in your source code repository in line with your source code, all the best GitOps practices fully supported. That's ideal. Or take advantage of the fact that those performance test assets may already exist. The performance engineering team has probably created something that you can just pick up off the shelf and leverage. And because you can also programmatically define, hey, there's an existing test out there. I want to use the test, but not the way the performance engineering team's using it. I want to create a new test with those assets that only runs for 5 minutes, that only runs 10 users, that just to validate, do that performance smoke test of this particular build of the application and do so in a reliable and consistent way. This gives you this kind of building blocks that you need to just leverage the work that's already there or programmatically create the work. That's really kind of the 2 main on-ramps. Practically speaking, what this means is when the pipeline is executing, kind of 3 things need to happen. First, you have to have access to the performance testing infrastructure itself. With Neoload and many other performance testing solutions, this means that you're going to need a pool of infrastructure to run load generators to actually host the virtual users, their computer programs. They need memory and CPU. Great, run those somewhere. You need access to some sort of API interface to trigger it, whether that's a plugin that goes into your CI system or a command line interface. Find that, whatever that happens to be, so that you can invoke the functionality programmatically. And you need some way to get the results out of the system so that you can see what you need to see. There's no point in a developer going in and saying, yeah, this will be great. I'll just programmatically build out a performance test. And then when it's done, I have to go log into this web portal that was built for the performance engineers to try and figure out how to read those results.
I was actually going to ask you about that. So how are people actually seeing this at the end of it?
So this is one of the strengths of the Neoload CLI, and I won't speak to other vendors that are out there, but this is also a strength that JMeter and Gatling and some of the other open source solutions have, specifically to the development community, let's say. And they're taking a step back. Shift left doesn't mean make the developers do it. A lot of organizations like to look at shift left and go, great, we'll just load that onto the developer's shoulders. That's not what it means. Please don't do that. The developers are very busy doing a job that hopefully they really like. Don't make them do things they don't like to do, because that leads to staff attrition and low morale and a lot of other issues. It means your performance engineering team gets involved earlier and starts creating tests when the developers are churning out the bare bones of the web service. You start testing it then. So and again, sorry performance engineers, you're gonna have to learn Git, gonna have to learn how to write workflow code, future state. I wish there was a better message, sorry. Ask ChatGPT, it's actually really good at building a lot of these things, even if it's only 90% right, just gives you the framework. Once you actually get there though, you've got involvement from these teams early on. What are the practical things that actually need to happen so you can do this? Well, first and foremost, what is your test? You need to be able to call the infrastructure, and you need to get the results. The results themselves get stored centrally. So again, speaking to Neoload, anytime I'm calling that command line interface, I'm actually leveraging Neoload Web, the centralized reporting, license management, user management, the enterprise feature set that comes with every purchase of Neoload, using that to run the tests. Two big things happen here. First, the results are stored centrally, so you always have access to them. And second, the performance engineering team gets to look at your results. They don't have to go somewhere else. They don't need to try and figure out what happened. But you don't want, as a developer, never want to log into Neoload Web, right? Tool is not fit for your purpose. You are a developer, you're not a performance engineer. We didn't build the tool for you for that purpose. So you call the CLI again. The CLI has robust reporting capabilities built into it to allow you to format custom reports in whatever format you want. You want a JSON output? You want CSV? Do you want HTML reports? What do you need? How do you want to format that report? We give you dozens of template files and the ability to customize and build anything you want. And then as part of your pipeline, embed those custom reports directly back into the pipeline itself. So now when you trigger the pipeline, it goes to Neoload Web, it calls the test. The test runs on infrastructure that Neoload Web knows about, often that it dynamically creates specifically for that purpose so that there's never any sort of resource shortage. This is one of the big benefits of Kubernetes. The test finishes, the results are stored in Neoload Web. Then next thing your pipeline does is say, generate all these reports and attach them to myself. And now you as a developer, you triggered a pipeline. 10 minutes later, you go and look at the performance results in the pipeline run itself. And the performance engineers can also see those results in Neoload Web. Nobody needs to go outside of the tool that they're comfortable with. This has a really big impact on things like productivity, where everybody can now look at their preferred system that they know how to use and never need to worry about whether they're talking about the same thing or not. Everybody's looking at the same data.
And they're on the same page. Yeah.
They're all on the same page. And this applies to our IT operations colleagues as well. Neoload supports integration into APM solutions like Datadog and Dynatrace, and not only can pull metrics from those platforms into Neoload, but also push Neoload test results into those platforms. Now your IT ops guys can be a participant in this performance conversation and look at the results of a performance test, but they can do so in their Dynatrace or Datadog dashboards or whatever else they're using, Prometheus, other things like that.
So that's really tip to tail there.
Tip to tail. Performance, continuous performance doesn't mean shift left. It's more than that. It's continuous across all aspects of the delivery tool chain. But using the car analogy from earlier, if I'm assembling a car, I want to test all the parts of that car before I put it together and try and do a road test. And I have a very high degree of confidence that if I have tested the drivetrain and tested the engine and tested the braking systems, that the car itself will work properly when I put the whole thing together. This can obviate a lot of need for testing. The testing done there is much more of a validation that the performance is good, not a, is the performance good? There's no question that it should be good. Unfortunate surprises are, of course, possible, but this is why you test. You don't guess. You don't take it on faith. Hope is not a strategy, to coin a popular phrase. And by going through all of this rigor earlier in the cycle, you get substantially easier and better results later in the cycle, where it would be much more difficult to fix an underlying performance problem. One of the phrases that I like to use is performance and security share a lot of the same characteristics. They are not features you bolt onto an application. They are inherent characteristics of that application. And if you have a poorly performing or poorly scaling architecture, and you've piled 20 features on top of it to fix that underlying problem may require you to take those 20 features off of it, make a change, and then figure out how to reapply those 20 features back on top of that newly changed infrastructure. It can be very expensive. Getting those earlier in the cycle is tremendously more cost effective than waiting till later.
So Bryan, one of the things that have come up in conversations recently with myself and other performance engineers is that when we talk about continuous testing, when it's functional, it's a pass or a fail. Either the function works or it doesn't work, it returns a 1 or a 0. But that's not necessarily the case with performance. And as you run these multiple test runs through different versions and you begin to see the trend line, at some point somebody has to make the decision from some rule that it passes, but now all of a sudden it breaches the 3 seconds, 5 seconds, whatever.
Yep.
There's a certain level. So it's functioning, it's working, but it doesn't meet the criteria. And that's not just an on-off thing, right? Can you address that, and how does that work?
Yeah, so performance is an incredibly subjective subject. It's tied very much to human perception, which is a notoriously unreliable actor. Ask any police officer who's taken eyewitness testimony and trying to reconcile the multiple different versions of what everybody saw that they've been receiving. The story that I have that illustrates this really effectively is I did performance testing for a rollout of a new teller application for a large banking system. And they rolled this, we did exhaustive testing, everybody gave it the thumbs up, we rolled it out, complaints came in, it was slow on Friday at lunch. They look at the data, there doesn't seem to be a problem. They go back and they look, Thursday afternoon, responds within 3 seconds. Tuesday morning, responds within 3 seconds. Friday at lunch, responds within 3 seconds. However, Friday at lunch, the line's out the door, and that 3 seconds feels a lot longer. You don't feel the impact when there's not a line of people standing behind the person you're trying to serve, but you sure do when there's 30 more people queuing up, and you're sitting there staring at that system, willing it to go faster.
Right.
Performance doesn't have a hard pass or a hard fail. You can set all the thresholds you want with a well-structured performance requirement, which includes the number of virtual users, the response time metric, and the specific transaction you're measuring. 250 users during the login process should take no longer than 3 seconds. If it comes out to 3.01 seconds, ship it. Yeah. Everybody's good, right? That extra hundredth of a second is not going to be the deal breaker, even though that's technically into the warning range or failure range, depending on how nuanced your performance testing solution is. So over time, how do you adjudicate performance? And this is tied directly back into things like the explosion of test results that you're going to see if you implement performance into your CI pipelines. Well, now that you get a lot of these results, machine learning starts to become your friend. This is where you look at those assistive programs, the artificial intelligence world, to help you analyze where do I spend my limited resources of time and expertise. The performance engineering team can't look at 1,100 test results a week. That's just not possible. What you can do, though, is have those test results get compared automatically to themselves. So, and you run the initial test, great, that responds in 2.1 seconds. Awesome. We're happy with these results. And we say every single retest that we run after this, compare it back to that first one. And our threshold is going to be 3 seconds. And at some point, what we tend to see is a gradual creeping up of performance over time, which is to be expected in a development cadence. I'm adding new features, new capability. The system is being asked to do more. It makes sense that it should slow down a little bit because it's got more stuff to do. And that's okay. But we set a threshold at 3 seconds. What we find in practice is that build 68 is fine, build 69 is fine, build 70 is fine, build 71 is a rocket ship. Right. And it shoots past that 3 second threshold dramatically. Well, everybody can see that, and now the performance team also sees that, and they can engage. We can help triage what just happened. And because we're doing this build by build, this is a new context for analyzing performance defects as well. We're seeing a dramatic regression in performance, but it happened between build 70 and build 71. So who checked what code in? What modules specifically were touched? What developers were involved? We can narrow the field of focus down to a much smaller subset of the application just through the nature of what the CI system already knows without trying to expand the scope of, looking at all of our performance observability data and our APM solution and other metrics that Neoload was collecting, we can start with something very, very granular and targeted very early on that gives us this really precise scalpel approach to trying to dissect what just happened in the performance result. That can be tremendously time saving. And by doing it very, very quickly, we're getting the developers while that stuff is still fresh in their mind. I just wrote this code, I checked it in, 30 minutes later, the performance team is talking to me about my code that slowed the system down.
Right.
That's great. That's not something to be ashamed of. That's not something to worry about. What's really awful is, as a developer, I check that code in, and 4 weeks later, they come to me telling me it's slow. Right. I can't even remember what I wrote. What are we talking about? What module? I've moved on. That's 2 sprints later for me.
Right.
I want to catch that as quickly as possible so that it's easy for me to fix it, so that I don't have an intellectually shifted context to something else. So these types of AI systems, we're releasing them in the next version of Neoload. They're on their way. You're going to see them in every performance testing solution over the next couple of years. They are absolutely going to become an assistant to that performance testing expertise to help you filter where you need to engage and spend your time, to tell you this test isn't meaningful. It's basically the same. Nothing bad happened. Don't worry about it. This test, however, this test was a disaster. Go talk to these people and engage.
Let me go back to the first question and your answer when we talked about these numbers and the low numbers of companies that really are on the cutting edge of continuous performance. And this could be real numbers or just anecdotal, but out of those companies who really do get it, are they experiencing this wonderful renaissance of great performance and you're never seeing their applications go down? I mean, are things still slipping through the cracks, or do they really get the huge value out of it?
So they are getting a lot of huge value out of it. And the problem is that the value they get is they're not reported in the news for having poor performance. Right? You got to feel for Best Buy over the years because they had a number of Black Friday incidents, but that's how you can tell that they have performance problems. Good performance doesn't show up. It's invisible.
Right.
It's very hard to quantify the value of that. And now we're talking about things like competitive advantage over your market segment. If you are an e-retailer and you are trying to sell things online, your competitors are things like Walmart.com, Amazon.com, and so forth. You need to invest to make sure you're at least as good. You've got a set of great benchmarks that you can rely on. If you can do better, that's going to help you. That's going to help your use case. You don't want people to visit your site and go, this feels slow compared to Amazon. I'll just buy it there. You want people to come to you and go, man, this is better than Amazon.
Right.
That's very intangible. That's very hard to quantify, but it's hugely impactful to the bottom line of a business, of an organization. Not least of which, of course, if you have a performance incident that HBO had when The Sopranos came to an end and their site immediately crashed and everybody thought that there was a flaw in the stream, you don't want those events either. So avoiding these with a proper performance strategy, all of the customers in that 5% that I talk to, they're never in the news. They never have a poorly performing application in production. They are rigorous up front and catch a lot of things up front, which leads to downstream benefits. Everything just works very seamlessly and is very performant throughout the rest of the tool chain by design.
So the goal is to keep out of the spotlight.
Absolutely.
So that's your motivation, performance engineers. Stay under the radar.
Have your company stay under the radar. You yourself, you want to be seen as, I don't want to use the word hero, but like a champion who's going to come in and help address the problem as quickly as possible so that everybody succeeds. Performance engineers, the developers, are not your enemy. They are your allies. You are all working towards the same goal. The corporation is the purpose. They're all paying you to accomplish the same task. Work together. There's no, I've never understood the shame that can come from, I wrote some code and it didn't work out and now I'm ashamed of that. No, great, this is an opportunity to learn.
Right.
So the only way I've learned is through my repeated catastrophic failures over the year. I got all sorts of stories about that, which I'm not going to put on video. So there's a there's a number of those moments that can really help, and the education that you as a performance engineer can give to a developer when you find a problem with their code and you explain why it's a problem. do you know what the likelihood of that developer doing that again is? It goes down sharply.
Absolutely.
And that is the longer term goal, that your developers get better and build great applications that test easily, that make your job easier. All of this is just a win for everybody involved.
I really feel sorry for you because I've never really made a mistake. So I've always wondered what that was like.
They're fantastic. I encourage it from everybody.
You mentioned about the mechanic and not changing your oil. This is just a little hint from my past. I've heard that when you go to mechanic school, the first lesson they teach you is just open the hood and just shake your head. You're already going to make more money. Thanks a lot for being on the show.
Pleasure.
Got it.
Good seeing you, my friend.
I'm sure that you've learned something, because I surely did, about continuous performance testing, and you're going to be hearing a lot more about that in the future. So, back to the whole Atlanta live event. Did I mention that at these live events we always have barbecue? No need to go to a barbecue place, just check out what the spread was there. Always a great time at these live events, and there's more on the way in the future. So that's another episode of the Performance Tour. I'm Scott Moore, thanking you for watching. We'll see you out on the road. Time for another adventure. Always a great time on the Performance Tour, and that's another edition of the show. I'm Scott Moore saying thank you for watching, and I'll see